Hi everyone, welcome to my channel. Today I'm going to try to solve a Google Codejam problem. To those of you who don't know what Codejam is, it's a coding competition hosted by Google every year to identify best coding minds in the world. They generally present algorithmic problems where more than one solution exists to a problem with different runtime, and their problems are really self-contained. So if you just read their problems, then you'll be able to understand the problem in general sense. Okay, so the problem that I'm going to address today appeared on Google Codejam this year only in 2017 in the qualification rounds. The problem is called tidy numbers, and here it is. So let's just read the problem. It says that Tatiana likes to keep things tidy. Her toys are sorted from smallest to largest, her pencils are sorted from shortest to longest, and her computers from oldest to newest. One day when practicing her counting skills, she noticed that integers, when written in base 10 with no leading zeros, have their digits sorted in non-decreasing order. Alright, some examples of this are 8, 123, 555 and 224488. She decided to call these numbers tidy. Okay, now numbers that do not have this property, like 20, 321, 495, 99990, are not tidy. Okay, so it says that numbers which have a property of that their digits are non-decreasing, which doesn't necessarily means that it is strictly increasing, because you have this number 555 here, which says this is non-decreasing. It doesn't have to decrease. Okay, so but it doesn't mean that it has to be strictly increasing, so there is a difference. Now she just finished counting all positive integers in ascending order from 1 to n. Okay, what is the last tidy number she counted? Okay, so let's just read the input and output for this moment. The first line of input gives the number of test cases, t lines follow. Each line describes a test case with a single integer n, the last number counted by Tatiana. Okay, output for each test case, output one line containing case number x is y, where x is a test case number starting from 1 and y is the last tidy number she counted, counted by Tatiana. Okay, so what I understand from reading this problem is that there's this girl who counts all numbers from 1 to n, and could be 1 and could be 100 or 1000 or whatever, and since we have a rule to identify which numbers are tidy and which numbers are not tidy, so let's say she counted to 1000. So we want to know what is the last tidy number she counted. So in case of 1000, it would be 999, which is a tidy number, since 1000 is not a tidy number, because zeros appear after 1. So the answer is 999. So we have to know, we have to write this program to identify what would be the answer. So let's have a look at the limits first. So the number of test cases is 100. Okay, so we will only have around 100 test cases, not more than that. And the small data set says the number she counted can be at most 1000, so it will be either less than 1000 or equal to that. Okay, so the problem is you have a number and you have to find the first tidy number less than it. So we can just run a loop starting from that number and decrease it by 1 and check if the number is tidy. That means that we can get this running in linear time. So that's great. Let's try that. So open up my Eclipse. Okay, first thing we're going to need is a basic input-output program, basic input-output system in place, which reads the input in a specified format from a file and writes the output in a specified format. We are going to call it. We are going to call this our crutch, just like an eggshell which protects us from outside world and interacts with it. Our crutch is going to interact with the input and store the output. Then we will write our code, which will contain our logic. Okay, I'm using Java 8 for this program just for the sake of code readability, and using Eclipse IDE for helping me out getting the function names correctly. But you can use any language you want to code, be it C or C++ or Python or any other programming language. Okay, so let's get started. So this is our basic program. Let's write our crush. Okay, so here we have our program. So I've just written our crutch of this program. So basically what it does is that it uses the buffer reader to read the input from this tidy.in file, and it uses the buffer writer to write the output in tidy.out file. Okay, and close both streams. And since first line of our input is the number of test cases, so I'm just getting the first line and converted it into int and showing a variable t, and just looping over t and getting all the numbers line by line. Okay, so in n we have our number, so we just need to find out if n is tidy. We just need to find out what is the last number less than n is tidy. Okay, so we can just do it by writing a function like is tidy n, and if it is let's just write a for loop first, because we have to decrease it by 1 every time. Okay, so I've used up I, so I'm using n. I am using j, and j greater than 0, j minus minus. Okay, so j is running over n from n to 0 and decreasing it by 1. Okay, so just need to check if j is tidy. That's it. If it is tidy, then I'm going to do something, or I'm just going to loop over. So let's just write our code in the format that is expected. I, and our number is j, and we just need to write this our tidy function, which will return boolean since we are giving it an int, and it will accept an argument, an integer argument. Okay, so now we have to write our tidy function, so which will return if the number passed in the argument is tidy or not. So what we are going to do is just using a very crude way of testing it whether our number is tidy or not. So what I'm doing is just getting all the digits of this number in a character array, and just checking whether the next element is greater than or equal to this the current character in the array. So if the next element is less than the current element, then we have a problem, and we will return false, since because that would not be a tidy number, or else if the loop completes, then we'll return true. Okay, so hope that clarifies a bit. You'll understand once we complete this function. Okay, so I've converted this number to a string, just a crude way to convert this number to string, integer to string, and then getting the char array, and I'm just looping over our char array using our variable I. I will run from 0 to character length and I++, and just checking if char I is, let's say, greater than char I plus 1. If that is the case, that means we have an element I plus 1 which is less than the previous element. So in that case, it is not tidy number, we return false. Or else, if the loop completes, that means that every number is in order, non-decreasing order, so we'll return true. Okay, and since this is I plus 1, so I think we'll have to have a -1 here. Okay, so this is our tidy function. So this will return if the number is tidy or not, and we'll just loop over n from n to 0 and check whether the number is tidy or not. If the number is tidy, we'll just break, because we don't want to go farther. We just need to have the first number which is tidy coming down from j. So I think that's it. Yeah, and one more thing, we write something to our output file. So we're gonna write the same thing, whatever we print from the console, and an extra new line, because system.out.println includes the new line. Yeah, so this looks nice. Let's just run it. Okay, so I'm going to try to solve the small problem. Okay, let's just rename this into our file name, which is tidy.in, and let's just place this file in our folder. Just copy this file and let's just run this program. Okay, it produces numbers, which I think is right. Let's just verify this once. So we have our few inputs already there, and first is 132, and second is 1000, and third is 7. The fourth one is I think it doesn't apply to the small dataset. I think it's for the large dataset. So we have our 3 inputs, 132, 1007, and the output is 129, 999, and 7. I think the first one is correct, second one, all 3 are correct. Okay, so we can just try to go ahead and put this file there in the location. Where is it? tidy.out and submit file. Okay, it says that submission of input small b rejected. Your output file contains 99 test cases instead of 100 as expected. Okay, so I think we have a little bit of problem somewhere. Yeah, here. So because I started with 1, so I have to have 100 till 100. So let's just run it again. Now it produces 100 test cases. Now just submit it again. Yeah, so we got our small dataset correct. So I think this will work fine for this large dataset also. Let's just try it. Okay, and now give this as tidy large.in. Okay, and let's just put this file same location, tidy large, copy file, run it again. Oh sorry, it has to be large. Now fingers crossed. Oops, we have an error, and that is number format error, number format exception for input string. Okay, this is a too big to be an integer, so I think taking it as long might do a trick. Not this one, but this one, yeah, this one I guess. Pass long, and let's just put it in long variable here also, and each tidy will take a long as an argument. That's it. Yeah, so let's just try. Okay, it got past 1 2 3, but it's not, I think it's stuck. Yeah, and this is because we have a very large input number as here, and even though we are running this program in order of n in linear time, it's taking just too much time. So I think this is not gonna work. This is not gonna work for our last data set. So we have to think something else. Okay. Now assume, let's stop this. Okay. Now assume you have taken your algorithm classes, and we understand that program that runs in order of log n is better than program which runs in order of n. By the way, there is another type of program which runs even faster than log n, and those are the programs that run in constant time. So it seems that we need a program which runs in constant time in order of 1, or at least in order of log n. Okay, so what can we do? So we cannot just decrease it by 1 and again and again and just hope that number is tidy. So this is not gonna work. Okay, so what else can we do? Let's just have a look at the input. Okay, so this is our number. So the first thing that comes to my mind is that we can only run this program, we have to run this program in constant time, or we have to run this program in log n. So log n means what? Log n means the size of the input. So we have this our large data set as the n can be of 10 to the power 18. Okay, so if we log that, that means that we get 18, and 18 is the size of this number, the length of this number. So if somehow we write a program that depends not on the number which is there, and we decrease it by 1 and 1 and 1 or some other way, instead we have to write our program in such a way that it utilizes the size of this number. So it is 18 in this case, it could be 14 or it could be 10, and doesn't depend on the number itself. So I think we are going to need a program which runs which has a loop over the size of it, over the length of it. Okay, so that's one thing. And okay, the first thing that comes into my mind is that let's say I have a number. Let's say this number is 100. Okay, and we want to find the last tidy number if we count from 1 to 100. So that would be 99. Okay, so how do we get to 99 from 100? So what we can do without doing the subtraction of 1, so what we can do is that we check the first 0, okay, and we just replace the first 0 with its neighboring left position digit, and convert all its right side digits to 9. Okay, so this is, we have the first 0. If we are reading from left, so we take the first 0 before the number, and after this number, if we take this 1 here, then we will have 1 0. Okay, so after switching this 0 from here to here, what we do is just we convert this to all of the digits in the right side to 9. Okay, so we have this 99, and we just remove the 0 from the leading position, so we have 99 here. Let's see if it works for 89. 89 is already a tidy number, so don't need to worry about that. 88 is already a tidy number, so 87. Let's say 87. So we have our first decreasing digit at 7. So just we have to take this digit to the left. So if we take it to the left, then it will become 78. Okay, and since we have to convert all the right side digits to 9s, so we convert to 9, so it becomes 79, which is correct. Now let's have an example of 86. 86, so we take 6 to the left side and 8 right side and convert it to 9, and this is not correct because 86 should also become 79. So it seems that this idea doesn't work, so we have to think something else. Well, what we can do, since we know that we have to run a loop over the length of the this number, not over the entire number, otherwise we'll never get from 10 to the power 18 to 1 within any reasonable time. Okay, so what we can do is, let's say if I have a number 87, okay, and I have this decreasing number, so let's just take this decreasing number, let's just decrease the left to this number by 1, so it will become 7, and all the right side digits, let's make it 9. So that's 79. In case of 86, it is 8, and after that it's 6. 6 is a decreasing number, so let's take the left number of it, which is 8, and decrease by 1, and make all the digits right to it as all the 9s. Okay, so far so good. Let's have an example of 110. Okay, so the first decreasing number is 0, so let's take this beforehand. Let's decrease the number 1. It will become 0 by 1. It will become 0, and all the right side digits to 9. So it is 109. Okay, so it is still not tidy. So we run again. We run the loop, the tidy loop again on this number, and this becomes the first decreasing number is 0, because it is after 1. So we decrease 1 by 1, which becomes 0, and make all the right side digits to 9. So it is 99, and we take the leading 0 out, so it is 99. So it is correct. The output is correct. That's fine. So let's have an example of 547. Let's say. Okay. So the decreasing digit is 4, because it is immediately right to 5. So let's decrease 5 by 1, which is 4, and do change all the digits to 9, all the right side digits to 9. So yeah, that seems to work. Let's just implement this. Okay, and let's see if it works for everything else that we are trying to do. Okay, So first thing first, what we're going to need is not a long or not an integer. We're just going to deal with strings only. Okay, we don't need to convert it to long or something, because we are not going to do any mathematical operations on it. We are just going to change, twinkle a digit somewhere and just change the digits. Okay, so let's just have a string, but better let's have our character array, because it's much more convenient to have a character array, so we can change bits on the go. Read line dot to character array. Okay, so we have our character array here. Okay, and now remember, we have to run a loop over is tidy or not. Is tidy, and this time I'm not going to have this number or anything. I'm just going to pass our character array here. Okay, and I'm going to have to change this method signature to character array, and now I don't need this conversion. Okay, and the rest thing is going to be the same. Okay, so I check whether this is tidy or not, and until it's tidy I'm going to loop over the numbers, because as we discussed, it has to be tidy, so we are going to loop over until we get a tidy number. Okay, so it is going to loop. So, and next thing, we are going to store the we are going to change the number. Okay, change the number in a sense, we are going to twinkle the bits, okay, from this to this and from this to this. So we're going to change the number. So let's write our function change number, and which will accept a char array. Okay, and yeah, that's it. Let's just write our function. It will return char array, and it will accept a char array. And this function, what this function is going to do is change the number until we have a number which is tidy. Okay, so what I'm going to do is just get the position of the first decreasing digit. Okay, so check first position, let's say, of this char array. So let's just write the function again. It will return integer, the location of the first decreasing digit. It will accept char array. Okay, and I'm just going to have the same kind of flavor in this function also. I'm just going from I to less than char length less than char length and -1. And if I'm checking if this is, if we find anything which is decreasing, then we just return this that position, or else we return char dot length. We are not going to get here because we already checked is tidy or not. So if it is not tidy, then only we are coming here, and since it's not tidy, we are going to get something from here. Okay, so we have our check first position function. So we have our first position of the first decreasing number, and let's just store this. Okay, so let's just change our digits. Okay, so whatever we have at position -1, because we are returning I +1, so we have to change it to position -1, and It's converted to string and then converted to integer, and this is all. I'm changing this to I'm just decreasing this to as -1. Okay, so if we have like 1 here, then I'll decrease it to 0, so that's fine. So sorry, I have to have still a -1 here. Okay, so this is my character, so I'm going to store this character inside of this character array at position -1, and I have a way of converting this integer into a character. I can always add 48 to it to convert it to ASCII and store it into a character array, but you can do it in C or C++, or so I'm just going to use this function. So it's nice to have a handle on things. So now we have our character position -1 changed, and now we are going to change all the other, whichever is right to the number. I'm going to change all of them to 99 or 999 in a row. So I'm going to run a loop with a variable I, and it is going to run from position I less than char.length and I plus plus, and it's just not going to do anything, just changing all the digits to 9. That's it, and I'm returning the character array. So yeah, that's it. So we have our change number function, and we are changing number and checking whether our number is still tidy or not. If it's tidy, then we just getting out and just printing it. Case number I is I'm converting this to this array, char array to string. Okay, and just storing the same in the file, output file. Sorry, not flush, to be right, and a new line. Okay, so that's basically it. I think this should work. What I'm doing is just checking, just getting the number, just checking is the number already tidy or not. If it's not, I'm just changing the number, and by changing the number I mean is that I'm changing the number in this way. If I find a decreasing digit, I change the left to it digit to a -1, and all the right side digits to 9999, and I'm repeating over in a loop. And once I come out of the loop, I just print the number, and yeah, that's it. So let's just try it now. Yeah, it seems to work. It didn't stuck, but still I have this leading zeros, so we can get away in Java like this, long dot parse long. I'm sure you can get around this problem in C++ and Python also. Just run it again. Yeah, so non-decreasing leading zeros are gone. So I think this will work. Let's just try it and see whether it does. So it's tidy.out, submit file. Yeah, that's correct. So there we have it, a program which runs in log n. Initially we had our program which ran in order of n, but now we have a program which runs in order of log n. Okay, but this program is far from optimized. Okay, so now here is a challenge for you. So can you optimize this program, can you optimize this solution so that it runs just a bit faster? Maybe you can optimize the is tidy function right here, or you can change, you know, the buffer reader. You can change the buffer reader to use something else instead of buffer reader, or maybe you can write you can change the core logic of it. Okay, or you can solve this program in order of 1, which that means that in constant time. Okay, so let me send me an email with your solution, and the fastest program, okay, for this problem will win a brand new Raspberry Pi. Okay, you can write your program in C++, Java, or Python only as of now, and the fastest program each of this language the fastest program for each of these languages will get a Raspberry Pi. So you have a chance to win 3 Raspberry Pis, guys. Okay, my email is in the description below. Send it to me with the subject line language of the machines, tidy number problem. If you like this video, please like, comment and share, and subscribe to our channel. If you like to see more cool videos, then please become a Patreon and help us run this channel. And until next time, stay tuned.